Science Uncut, presented by the Volkswagen Foundation.
Thank you, Lars, and I would like to thank the Volkswagen Foundation for having invited me to this real learning experience. I'm really learning a lot. And most of all to Simon Wayne Hobson, who was most instrumental for me being here. Anyway, I would like to, there's 4 parts to my presentation. First, I want to tell you about the Soviet biological weapons program as a case study. And then the program that was called FERMENT, so that was involved with gain of function in its time. And then talk a bit about the Biological and Toxin Weapons Convention, and finally the not so pleasant future of weapons based on genetics. There are 2 generations to the Soviet biological weapons program. First generation was one that used classical applied microbiology techniques, mutation selection and propagation, to weaponize this list of agents, including botulinum toxin, which is a chemical, and that was kind of dropped and it became, after this time, became part of the chemical weapons program. So the second generation program was codenamed FERMENT. There was actually 2 parts to the second generation program. FERMENT, which was objective was to develop weapons that would kill or hurt human beings. And the second part was called ecology, and that was to develop weapons that hurt or killed animals and or crops. So as you can see, the objective was to utilize genetic engineering to endow known pathogens with unique properties. So you can read this yourself, and I just want to then continue by saying that this was a huge enterprise. There were, I'm going to talk about some of the institutes, but it probably employed something like 60,000 people, and it did the world's most sophisticated large-scale use ever. And you can see here that the institutes were all over the place. Vector in Novosibirsk, Stepnogorsk was a production plant, and then a lot of these institutes, some were right around Moscow, and one in Moldova, and so on. I should mention that in 2003 and 2004, I was a manager for 3 projects in former Soviet biological weapons plants. 2 were in Obelensk, they were located close to Moscow, and 1 in St. Petersburg. So I got to meet a lot of scientists that way, and got to, of course, see the facilities. I wish I could show you some pretty pictures I have, that these places were immense, really immense. But I'm only going to show you one picture in a little while. So there were 3 Ministry of Defense biological warfare facilities in Kirov, Zagorsk, and then in Sverdlovsk. These are all exist today, and they are as secretive now as they were in Soviet times. So the one in Sverdlovsk, Peter mentioned that it used to be a production facility until that had this accident in 1979. And by the way, there's no question about it, they were working with biological weapons, not possibly. They were, the strain 836 in Bacillus anthracis was released and caused this outbreak. After this happened, they closed down the production plant and they moved it to Kazakhstan and became part of the biopreparat system. Unlike the previous institutes, biopreparat was a civilian facility, so they hid this in plain sight. What they did is they set up this biopreparat system, and it was under the supposed authority of something called Glav Microbioprom, which was the main board on biotechnological industry. But actually, they reported to the Ministry of Defense. So all these, as you can see, they are 5 institutes that were the most important, but in addition to that, they had all kinds of subsidiary institutes that helped things like instrumentation and so on. The ones that I had projects in was the one in Obolensk, and the one that was in Leningrad, now it's St. Petersburg. And then in addition to that, when the Cooperative Threat Reduction Program, DITRAS program, was destroying the Progress plant in Kazakhstan, in Stepnogorsk, I was able to visit that also. In addition, there was the Anti-Plague Institutes. There were 6 of them in Soviet times, 5 in Russia, and 1 in Kazakhstan. So most of these institutes were involved with the defensive program, which was codenamed Problem 5. And some of them were, one of them was part of the offensive biological weapons program, the one in Volgograd, which worked on Burkholderia for offensive purposes. Now, all of these are closed. Not as much as closed as they were in Soviet times, because their scientists can move around without the KGB looking down the neck. And for example, I was at the International Conference on Yersinia pestis in Shanghai a year and a half ago, and there were 8 people there, 6 from Russia, 6 of them came from anti-plague institutes. So they are able to do that. But only 2 foreign teams have been able to enter this one, the microbe. One was a team from Livermore National Laboratory, but they only got to the conference room. And then a Swedish team in 1996 were able to get in for a short stay, but also didn't get to see the laboratories. So they are also closed. I should tell you that I have a publication. We have 3 reports on the Soviet anti-plague system. We're the only ones who have done any, as far as I know, in the West work on the anti-plague system. This is the last report. It's called Stories of the Soviet Anti-Plague System. I'm going to leave this sit, and if anybody wants to look at it with my other book, which I'm going to describe in a second, you're perfectly willing. I mean, you perfectly can do that, no problems. So FERMENT had a bunch of sub-projects, and I don't have enough time to talk about all of them, so I'm just going to give you some examples. The 3 that are listed here. So the factor project goal, higher virulence, higher stability, and surprising new outcomes. And the examples that I give that I really liked was the attempts to use, or they actually did it. They moved Ebola virus genes to the vaccinia virus to affect hemorrhagic symptoms in animal models. And then the second one, the diphtheria toxin, Corynebacterium, to Yersinia pestis to make it more virulent. And the one I really like was to move, as you know, I'm sure that works with Bacillus thuringiensis. It's not hemolytic. Bacillus cereus is, but it's not such a serious pathogen, but it does hemolyze red blood cells. So they tried to move the genes responsible for that into Bacillus thuringiensis to make it even more virulent. But they had surprise outcomes. And if you want to talk about that, I'll tell you about it. Really, it just floored me when I found out that it had to do with blindness, causing blindness in people that were infected with this particular construct. The Hunter project was to develop hybrids of bacteria viruses, and the one that I liked is that they made a DNA copy of the VE virus and hooked it up with a tetracycline promoter and inserted it in Yersinia pestis. At that time, the most common antibiotic used to fight or to cure plague was tetracycline. So you can imagine what happened when this particular construct was used as biological weapons. People came down with plague. They were given tetracycline, and lo and behold, they ended up with encephalitis. Third one, Chimera Project, developed viruses containing exotic genes. And there they worked a lot with the vaccinia virus. Vaccinia virus, of course, is the DNA virus. And it's very nice for this purpose because it's a big virus and it can take a lot of genes into it. So it was easy to work with. Unlike RNA viruses, which are very, very tight and they don't like to have any genes put into them from foreign sources. So obviously the vaccinia virus was a surrogate for Variola major. And I'd like to show this. This is the typical production plant in the biological. These hold 5,000 eggs apiece. And when they were doing full production, the whole region would end up not having any eggs. And they all went into use for huge, large-scale production of different viruses. This Pokrov Institute, it's part of the biopreparat system. It was a production plant, and it still exists. Now, Vector, one of the biopreparat that was in Novosibirsk, still works with influenza virus, and when they do produce vaccines, they do it at this place. Talking about dual use. Okay, here you have the workhorse of the Soviet biologic weapons program, the Gerish 305 bomblet. And this I want to mention, and I hope if nothing else you remember from this presentation, biological weapon is a system. When people say smallpox is a biological weapon or V is a biological weapon, that's not right. It's not right at all. It's a system where you have the payload, which is obviously a pathogen, and then you have the munition, which contains the payload, and then you have a dispersal mechanism of some sort. So in this particular bomblet, the dispersal charge is TNT. It's an explosive, but it could be compressed air. It could be different kinds of what they call energetics. But you have to have all four. Even the Amerithrax envelopes were a weapon. You had the formulation, the spores, you had the envelope, the munition, and you had the nervous secretary wafting it around and dispersing the spores. So remember that, please remember that. So that mysterious document that you have in front of you, it's called RU2 something. What that is a Russian patent of a new improved bomblet that can be used as a cluster weapon. Now, I'm sure if you asked a Russian military what they use that for, they would say, "Oh, we use it with regular explosives like TNT." But if you look at this description, which we went to their website, the patent website, and we translated it from Russian, you can see that it's rather easily adaptable for the transport of biological preparations. So we've seen this before. Recent gain-of-function research has to do focus on pathogens, MERS, SARS, etc. And the objective is to increase the ability of pathogens to cause disease by enhancing their pathogenicity or increasing the transmissibility. Most yesterday was talking about transmissibility. So, okay, now the short description of the FERMENT. Objective was to enhance pathogens' abilities for infection and virulence, endow them with new capabilities. And these were top secret, of course, and the intent was purely malevolent. Now, with 2004, with gain of function, difference, of course, is they're completely open, transparent, and the intent, ultimately, even right now, you're talking about transmissibility, the ultimate benefit is to help biomedicine and public health. But the comparison, as you can see, is they're very similar, technically speaking. Now we move on to the Biological and Toxin Weapons Convention. When I have a co-author, Milton Lightberg at University of Maryland, of this book. And I should mention I did the first part, which is technical. So I just went through the technical part, which is about 400 pages, in 10 minutes. So there's a lot more to it, as you can imagine. And I will also leave that sitting, so if anybody wants to look at it, you can. But when most of the information came from weapons scientists or former weapons scientists, and everyone that I met, and there were about 15 of them, I asked them, have you ever heard about the Biological and Toxin Weapons Convention? And out of the 15, 13 said, no, I never heard of it. And 2 said, well, I kind of read about it in a newspaper, but I don't know anything about it. So then the question was, well, was this kept away from them by the Soviet government, or was it just like, working scientists keeping their nose in their laboratory and not getting out of there? Well, when I came back to the United States some months later, I was invited to this virology conference at Fort Collins, Colorado. And they were most of the virologists there were Americans. So I went around and interviewed 4 of them, just hey, you. And asked them, well, have you heard about the Biological Weapons Convention? None of them had heard about the Biological Weapons Convention. 2 years ago, I was invited to a Gordon Research Conference in Ventura on biodefense research. There were people there from Porton Down, which is the old British biological warfare facility, but now, of course, only do defensive work. So I asked 3 of their scientists, young scientists, who were all working with Bacillus anthracis, have you heard about the Biological Weapons Convention? They all looked at me with big eyes and said, never heard of it. So this means to me that now you are, maybe some of you have never heard of the Biological Weapons Convention, but now you'll hear about it. There's no excuses for you anymore. So but I'm only going to give you the Article 1. Article 1 is pretty straightforward. Nobody, state parties, we're talking about nations, undertakes never to develop, produce, stockpile, or otherwise acquire, retain, and you can read it yourself. The interesting part here is that there's a word missing, and the word is before development, there should be research. Research is not mentioned, which means that all research, whatever its intention, is permitted under the Biological Weapons Convention. And the second part, you see that you can do all kinds of defensive development, etc. And that's within the you're okay with the Biological Weapons Convention. So how do you differentiate what you can do and what you can't do under the Biological Weapons Convention? Well, in 1989, I had a conference at the University of Maryland. I asked a very, very good friend of mine at that time, David Huxell. David Huxell at that time was a director of the U.S. Army Medical Research Institute for Infectious Diseases in Frederick, Maryland. And I asked him, how do you differentiate? So he came up with this. And this is very neat. So on one hand, you're trying to weaponize a virus. On the other hand, you're trying to make a vaccine out of the virus. And you can see that in the research part of this, they're exactly the same. So that's the reason why they didn't include research in the weapons of the BWC. Because if you came in as an inspector and you were investigating, you wouldn't know what the intention of that research was by looking at what's happening here in the research phase. It's not until you get into the development where you attenuate or kill the virus in order to make a vaccine, but if it was a weapon, you make it more virulent or more hardy or more infectious and so on. So this is really neat. I think he really did a good job. And I hope sometime somebody will do something like this in bacteria. Maybe David Relman, you can do something like that since you're such a, good bacteriologist. Okay, now, did the Soviet Union actually possess an offensive biological weapons program? Well, the Yeltsin came into power in 1992, and he said, the Soviet Union, had an offensive program, and we were breaking the Biological and Toxin Weapons Convention. And he also, under these so-called, there's this, he had to turn in these reports every year under the confidence building measures to all the other states. And even in 1992, in that report, they said we had an offensive program, but we don't do that anymore. And he ordered that the program would be closed. Now there's a history there because Boris Yeltsin was, in 1979, he was in effect the governor of the Stepnogorsk, or the Sverdlovsk Oblast, or the province. And when this outbreak of anthrax happened, he was, of course, very disturbed. He was governor, and nobody would tell him anything. The KGB wouldn't tell him anything. The Department of Defense, or the Ministry of Defense wouldn't tell him anything, and that really upset him. So that's probably one reason why he said, they lured me, and he, in interviews in 1992, and so on. But then, when Vladimir Putin became president in 2002, they changed that. Oh no, we never had an offensive program. We only did defensive research and development. And what did we have these weird constructs for? Well, we did it because we wanted to have them to be able to develop defenses against them. And that is their official view to this day. So what is the legacy? Well, the 3 Ministry of Defense institutes are closed and they're secret, as in Soviet times. The biopreparat facilities for a while were transparent because they all were starving to death, so they started taking money from the Cooperative Threat Reduction Program. And when they did that, they agreed to be transparent. So each program that was funded, or each project that was funded in the biopreparat institutes, had a collaborator from the United States. So that was pretty transparent. But starting, and I was there, I visited, they had no problems in 1993, 1994. But then Putin started closing them down. The Cooperative Threat Reduction Program was closed down. The International Science and Technology Center was closed down by Putin last year in 2013 and moved to Kazakhstan. And so now we really don't know what's happening in the biopreparat institutes anymore. And then, as I told you about the anti-plague institutes, they are very secretive. We don't know how, under what kind of conditions, the constructs that I was telling you about, plus there are many more, how they are kept. And we have to really worry because there's a lot of corruption, including in the Ministry of Defense and in the generals and all soldiers from the highest generals down are on the take, in effect. So in March 22, Putin was premier. If you remember, he was president, and then he was premier, and then he became president again. So, and he was running for president in March. He gave an interview, and he said, we have 28 tasks that I'm going to try to do if I became president again. And under this plan called the Strategy 2020. And he formulated these 28 tasks, and they were published, and I have copies of that. And then when he was elected, they had a meeting with all his ministers, and the Minister of Defense at that time was this guy Saduyukov. He says, we're going to do everything that you want done by the Ministry of Defense, including Task 4. And you can read this. Task 4 is based on weapons on new physical principles, and as you can say, genetics is part of that. So what is a genetics program? What is genetics, weapons based on genetics? He didn't define it, but we found in the Russian Ministry of Defense has a website, and they have a glossary. So this is directly taken from their glossary. The only thing we did is translate it from Russian to English. And this is a site, if anybody's interested. And you can read what a genetic, what if, I assume that Putin knew what he was talking about, that they're going to develop weapons based on genetics. So this is what it's all about. I don't have to read it to you, but you can imagine that this, I think is pretty damn threatening myself. So then what I'm really worried about then is that there's going to be a third generation of BW program that was going to be established or set up in Russia, today's Russia. And they, in the Secret Institute, they have all these constructs already. They have a lot of experience with the developing biological weapons, the whole systems. And all they got to do now is to, guess what? Use gain of function type of genetic engineering to become even more advanced than they were before. So, please, your turn.
So thank you, Raymond, for this interesting but rather not very optimistic talk, I guess.
Oh, really? Is anybody optimistic about Putin? He breaks international laws, that's what,
So are there any direct questions to this talk before we start with the discussion? Yes, Mr. Feinberg?
In a way, your talk is curiously reassuring about the risks from gain of function of influenza research, because one implication of the talk is that there are already so many options available for devastating use of biological offensive weapons if desired, that an uncertain potential use of influenza would be pretty far down on the list of desired weapons if that's what you're after. I wonder if you could reflect on that.
Well, I don't exactly know how to estimate risk in this fashion. And the Russians or the Soviets did have some accidents, but actually very few accidents in their biological weapons program. They had one person die of Marburg. They weaponized Marburg, not Ebola, but they never did they weren't able to do any genetic engineering with the hemorrhagic fever viruses, probably for the reasons I already told you. But on the other hand, variola is pretty easily to work with, apparently, according to them anyway. But the question is, it's hard for me to measure the risk that they posed. I'll never forget, I was a fellow at the U.S. Arms Control and Disarmament Agency, and I've gotten my top secret clearance and all that. And I was getting this information. At that time, this was in 1993, Alibek was a second defector from the biological weapons program, and he was being debriefed. And we were getting the reports, the classified reports at that time. And one of them was that he was telling about their program that was the weaponization of variola. And that was one of their main biological weapons agents. And I was thinking, man, this is the most irresponsible thing I've ever heard of. The world is completely vulnerable to it, and they're working on it, and by the way, there was an outbreak in 1972 on something called the Vozrezhdeniya Island. They were testing that bomblet that I showed you, and and part of the payload escaped, and it was contracted by a Soviet researcher, a marine researcher who was on a marine vessel going by. And she then took it to Aralsk, and they had an outbreak of 14 people, and 5 died. So I was thinking, how can anybody be so responsible? And I'm going to go to Washington Post, I'm going to tell them all about it, and they're going to, hell with the classification. Now, I didn't do it, but that's how I was feeling at that time. Now I can talk about it because, but I can't tell you. I don't know the risks of it, and it's a hypothetical thing still. They have them, yes, they have the constructs and all that, but are they going to do anything about it?
One more direct questions before we start with the discussion with the other speakers. Yes, please. Dr. Fouché.
You seem to be surprised that research is not covered by the Biological Weapon Convention. I'm not so surprised because we cannot even control the biological weapons by this convention. So why would you even try to cover research? It's only going to block research, and it's pretty ineffective.
Well, I'm sorry you misunderstood me because I actually am not. I explained why I think research are not covered, having to do with and that first part of the figure I was telling you cannot tell the difference. So if the Biological Weapons Convention is to be used for example, it doesn't have verification. It's a weak treaty, but if there is going to be an inspection by, for example, the Secretary General of a suspected biological event, and they walk in the laboratory like we did. I was an inspector in Iraq. And you walk in a laboratory and start inspecting. If they're just doing research, you have no way to tell what the intent of that is. So I think it's very. I think it's proper that research is not in the Biological and Toxin Weapons Convention.